Can y'all hear me now?
Yes.
Yes.
All right, evidently I cannot hear you. Someone say something? Oh, I'm sorry, I'm talking to Zoom. Are we supposed to be there?
Yeah.
Ah, damn, sorry guys, I gotta come back. I'm in the wrong room. I can't, you know. Okay, can y'all? All right, this stupid, can y'all hear me on in the Zoom?
Yes, we can hear you.
Okay. So. Try talking to me again, because I don't know what the devil's going on here.
Hello.
No. That's not the problem. You can hear me, but I can't hear y'all. Evidently, IT came in and worked on this machine to keep sequence. It looks like so we're gonna have to do it this way. Oh, how lovely. And now it's not seeing my. Oh. This is what I hate having to do every time I come in, is to do this. It doesn't remember my settings. And where is it? Yeah, Um, the camera and apparently the microphone and speakers are really screwing up big time. So we're gonna have to do what I do in my Tuesday afternoon class, Tuesday, Thursday afternoon class. And that's use my wimpy little camera. It does a good job as a desktop webcam, but so can you all hear me fine? Not what I was looking for. And, okay. Oh, got the camera now. Let me see if it'll go to the right place. Oh. Try this. Now, nope. Let me do this. Yes. Oh, too far. Not too far. Oh, crap. So y'all can hear me okay. Oh, yes. We need to go to that camera. We'll go to that camera. So I'm gonna leave it there. Oh, I know what I'm saying. And yesterday morning, I was in the wrong classroom. Oh, I need to get the sign-in sheet out. Hold on. Get to sign in online easy, you just. So, when you get a chance, make sure you sign in before you leave today. This is- The question becomes, again, where do we leave it off? And we started graphing the sine and cosine.
What's that, 1:30?
1:30. Okay. This one. Okay. That needs to go away. This needs to come back up. Here. All right. Making sure, yeah, okay. So graphing using key points. The key points for sine at 0, at pi over 2, it's 1. At pi, it's 0. At 3/2 pi, it's -1. And at 2 pi, it's 0. So those are the key points. Now, have we discussed graphed cosine? No, okay. So I'm going to deal with this in a moment. But right now, I'm going to deal with this 4. The 4 out here means we're multiplying the y values by 4. So I'm going to change all these points, all the key points, by multiplying by a. Okay. So we identify a is 4. So I'm going to multiply each one of these by 4. The y values. So 0, 0 is going to stay there, and pi over 2 jumps to pi over 2, 1 jumps to pi over 2, 4, and this stays at 0. And now this jumps up to 3 pi over 2, -4. And this one stays on the x-axis, because 0 times anything is still going to be 0. Now, the next thing we're going to change is the x values, because we're changing x. So if we're multiplying by something, we're multiplying x by a negative pi over 4. So that means I'm going to, the reciprocal of this is a -4 over pi. So I'm going to multiply each of the x values, each of the x values by -4 over pi. The negative sign in there means I'm gonna do I'm reflecting across the y-axis because I'm changing the sign of my x's. And then dividing by 4 with transformations, if you're dividing x by a number or you're multiplying by a fraction, yeah, that's less than 1. So this is going to be a stretch, a horizontal stretch. So my x values are going to be moved away from the y-axis. So I'm flipping it and I'm pulling it apart. So I multiply 0 by -4 over pi, which is still 0, 0. So I'm gonna do -4 over pi times pi over 2. Yeah, this was a wrong one to use today. Okay, so those go away, and this reduces to 2. So this is just a -2. And the 4 didn't change. And multiplying pi by a -4 over pi is a -4. And 3/2 pi times a negative pi over 4 becomes a -4 over pi times 3 pi over 2. Those go away. This goes to 1. This goes to 2. So this is a -6. -6, -4. And the 2 pi 0 becomes, what is that, 8 pi 0? I mean 8 pi, just 8, -8. Yeah, -8. 0. So where the sine function would look like this. So multiplying by 4 on the outside is a horizontal, a vertical stretch. And so it makes it go like this. Oops. Down further. And then the negative aspect of x would, and they're going to deal with the negative aspect and then look at the fraction. And so the negative aspect just flips it across the y-axis. So now it goes like this. And then multiplying by a fraction less than 1, because pi is 3.14 approximately divided by 4, and that's going to be less than 1, greater than 0. So, and we dealt with the negative aspect with the blue graph. No, yeah. And so if you're changing your x by multiplying by a fraction less than 1, positive fraction less than 1, then it's a stretch. We're pulling it away from. And so it's going to make it go wider. So it's like you have a slinky laying on the ground and you pull it apart. So that's what we're doing. And so these are the key points we can graph. Because this key point was rock solid, so it didn't do anything. But this one got moved over here and then is pulled this way. Right? 1 pi over 2 went down here to -2. Which is a little shy of pi. Okay, this pi is 3.1 or negative pi. And so this point got moved all the way over to here. Which means this point would get moved to here, over to here. So I'm just flipping it across the y-axis. And they do their pictures look nicer than mine. So, but that's why I like to do it this way. I like to list the key points. And then what happens to each of the key points? So now we have 0, 0. And we have -2, 4. And then we have -4, 0. And then we have, whoops, getting too close. -6, -4. And then we have 8, 0. And so that's how it's going to go. It's going to at 1, 2, it's going to be at 0, at -1. And at 4, it's going to be at 0. And at 6, it's going to be at 4. Because now it's a symmetric with respect to the origin. Sine is symmetric with respect to the origin. So this is a -2, 4. So this one's going to be 2, -4. This is -4, 0. So this one's going to be 4, 0. -6, -4 is going to be 6, 4. -8, 0 is going to be 8, 0. So it has a mirror image across through 0. So let's look at what they say here. Oh, it's negative. Oh, I see what they did. Yeah, I was wondering about that. Because sine is an odd function, I can pull this negative sign out of there and then deal with that. Well, then we're going to get these points over here, not these points down here. Making sense? So the way they were doing it, they rewrote it this way. So now we're going to be multiplying these x values by a +4/pi. And we're going to multiply the y values by a -4. And so that would give us 0, 0, 2, -4, 4, 0, 6, 4, and 8, 0. So they would be graphing these points, and that's an easier way to do it. Is use the even odd properties of the function, so you don't have a negative sign inside here. Okay. Yeah, and they do it differently than I do. Okay, so now the period is 8. All right. Sine has a period of 2π. And when omega is anything but 1, you divide the period by omega. So dividing by pi/4 is the same thing as multiplying by 4/pi. So multiplying 4/pi times 2π, well, we get the same thing, which is 8. So now we take 8. So we have from 0. So now my period is from 0 to 8. And I'm going to divide it into 4 regions. And this is 4, this is 2, and this is 6. And the key points, the key y values are 0, 1, 0, -1. And then back to 0 again at 2π. Okay, yeah. I didn't have it there. Okay. And so this is 0 is at 0, 0 is at 0, 0. And so 2 is gonna be at 2, 1. And then 4 is gonna be at 4, 0. And then 6 is gonna be at 6, -1. Is that right? Yeah. And then 8 is gonna be at 8, 0. And then you bring the amplitude in, the amplitude is 4, and so that 4 is going to change our y values by a factor of 4. So we multiply each of these by 4, the y values by 4, just like we did over there. And we get 0, 0, 2, 4, 4, 0. 6. Oh, no. But we multiply by 4, by -4. So that's 2, -4. And 6, +4. And 8, 0. Yeah, we're still multiplying by a, by the -4, whatever a is. But the amplitude is the absolute value, because that gives you your high and low. The negative just says you're gonna change your maximum to your minimum and your minimum to your maximum. That's all. You're changing your direction. Negative means you change your direction. Money's going out instead of in. Okay. And how they set up, I think how they set up the I'm gonna screen. I've never had so much trouble. You can't see the top of the screen. Okay, I'll change that as soon as I get my PowerPoint back up. What slide were we on? Huh. Let me see, graph of. Okay, let me move this up. Okay. Just. Okay. So, yeah, you divide the interval into fourths. Now I do it, I put it on the number line rather than doing it that way. I put in a number line and dividing it into fourths, you take half, and then each half you take half. And so that divides it into fourths. I just think that's a lot easier than the way they do it. So the first coordinate is 0, and the next one you're adding 2, and the next one you're adding another 2, and the next one you're adding another 2, and then you wind up with, you have all 5 coordinates, and it's divided into 4 regions. And so, sign of 0, 0. And so, yes. And so I look at these, all they're doing is multiplying 0 by -4, and then they're going to multiply 1 by -4. Well, I have my numbers over here. Now they're going to multiply 1 by -4, and they're going to multiply 0 by -4, multiply -1 by -4, and then multiply 0 by -4. So that's how they do that on all those, and so they got the same points I have here. So knowing these key points here, these key points for sine, knowing those key points for cosine, and the key points for cosine are 0, 1, pi over 2, 0, pi -1, 3/4 pi, 3/2 pi is 0, and 2 pi is 1. So knowing those key values, those key points for sine and cosine, really make doing the transformations a lot easier. And I wish they would show it. So this is the first. This is the first quadrant period for this function, and then you just continue it on down and up to show it how it's going. Most times I probably come down to a half a period this way and a half a period this way, just to show how it's going beyond that one period. So I extended out plus and minus 1/2 period. So I go down to -4 and go up to 12. Okay, so this one is going to be very similar, but it's with cosine. So omega in this case is pi. Oh, and they have the added feature of this -2 here. So looking at this is in terms of transformations, we're having a compression in the x. So we're squinching it towards the y-axis. We're having a stretch in the vertical, so we're pulling it away from the x-axis, and we're flipping it across the x-axis because I'm changing the sign on my y values, and then we're moving the entire graph down 2 units because this is a vertical shift. Damn it. Okay. This morning's been very frustrating for me. Okay. And I still on Zoom. Okay, assignments. I have to check that constantly because the camera doesn't work at all in Brazos 218. I mean, it comes on, but the machine doesn't recognize it at all. And then one of the cameras keeps cutting out on me, or the Zoom keeps dying on me. Do that in here, I think. Okay. So for cosine, the key points are 0, 1. Because so if you look at the unit circle, these are the x values on the unit circle for the quadrantial angles. Okay, here is 1, 0, 0, 1, -1, 0, and 0, -1. And this is pi over 2. And this is pi. And then this is 3/4 pi, or 3/2 pi, sorry. And this one is 2 pi. 2 pi and pi have the same x and y value. And so we're just looking at the x values for these. So 0, 1, 1 for angle 0, the x value is 1. For the angle 2 pi, pi halves, the x value is 0. For the angle pi, the x value is -1. For the angle 3/2 pi is 0. The x value is 0. And for 2 pi, we're back to 1. The x value. Now we do these transformations on these ordered pairs. Now, one thing to look at is I'm going to look at the same thing to come up with these numbers here to see where my x values wind up. My period is pi. Omega in this case is pi. So that means I'm going to divide my period 2 pi by pi. Well, yeah. The period is 2 pi divided by omega. And with omega being pi, this becomes 2 pi over pi, which is 2. So my number line, my single period is from 0 to 2. Halfway is 1, and the first quarter is 1/2, and the second quarter is 3/2. So that's what my x values go to. So now this is 0. This is 1/2 0, 0, 1, 1/2 0, 1, -1. What is it? 3/2 0, and 2, 1. Now everything else happens to the y values. Okay. I'm going to multiply each y value by -4 because that's what the amplitude is. Or that's what A is. The amplitude is a +4 because we're going to take the absolute value of -4. But what that does is I'm multiplying each of the y values by -4. So this becomes 0, -4. This becomes 1/2 0. This becomes 1, 4. And this becomes 3/2 0. The 0 times anything is still 0. And 2, 1 becomes 2, -4. The first point and the last point should be the same. Now, the last thing we do is this -2. And so that means I'm shifting each of the y values down 2 units. So this is going to go through 0, -6, because -4 minus 2 is -6. 0 minus 2 is a -2. So that becomes 1/2 -2. 4 minus 2 is 2. So 1, 4 moved down to 1, 2. The 3/2 0 moves down to 3/2 -2. And the 2, -4 is going to have the same y value as the first point, 2, -6, because -4 minus 2 is -6. And so graphing that, I have 0, -6 down here. So I'm going to say this is -6. 0, -6. Okay, so 2, 1. So I want to see what happens at 3. So that's going to be, what is that, 5/2. And this is 3/2. And this is 1/2. So I'm going to want to see what that goes down here to -1. So I'm going half beyond on either side as well. And so at 0, it went down to -6. At 1/2, it's at -2. And at 1, it's back to, it's at 2 at 1. So 1 is up here at 2. And at 3, it's 3/2. It's at 2. And then at 2, it's back down to -6. So 5/2, it would be this point again. And at 3, it would be this point here. And then at -1/2, it would be this point. And then at -1, it would be this. Yeah, it would be that point. So it goes like this. If I can hit my points. I can't hit the points, Mr. Reed, because I'm not an artist. And I didn't do any graphing till the end because I looked at what happens to my key points. So begin by graphing the function. So A is -4, omega is pi. So the period, the amplitude is 4, and the period is 2, which is what we got. I always look to see what the period is first and then the amplitude. But the amplitude is kind of trivial to find. And what number is that? So they're saying the range for the graph for this function is from -4 to 4, including. So on the y-axis, going from -4 up to 4. And then one cycle begins at 0 and ends at 2. So dividing that into 4 regions. Okay. So each other region is 1/2, and you find the 5 key points by adding 1/2 and then adding one. Well, I like to do it on the number line. It's a lot easier to calculate those values. Okay. And so you look at. So at 0, it went to -4. They didn't explain how you got those values. And I kind of like to go through it step by step. So what's the first line? Oh, the first slide is just a single period. And here they extended it. Oh, yeah, this is before they do the -2. And so this graph and this graph, this one has just been shifted down 2 units for this one. So here they're showing each transformation, where this is also showing each transformation, just not on the graph. They're showing this, it's showing the transformation, what happens to each of the key points as you apply. And they did it a little differently than I did, but I think they went to here first. They didn't start with this. And then they went straight to this. They skipped this line here and went straight to this. Because they changed both the X value and the Y value pretty much at the same time. And I don't like to do that. It confuses me, so I like to do it a step at a time. Even there, I get confused sometimes. So the domain is all real numbers. And the range is from -6 to +2, including the endpoints. Okay. So Y is between -6 and 2 inclusively. Now we find an equation that fits this. Okay. It goes through 0, 0. So I'm going to say this is sine of X. But it doesn't go down to -1, it goes down to -2, and it doesn't go up to 1, it goes up to 2. So I'm just multiplying by 2. So now it's going to be 2 times sine of X. Now, one iteration, one period in this picture is from here to here. So that's 4. So my period is 4. But 4 equals 2 pi divided by omega. So I need to find out what omega is to give me what X is being multiplied by. Or being divided by. So I'm gonna multiply by, yeah.
Excuse me,
Yes.
where did you get that 4 equals 2 pi over omega?
The period for sine is 2 pi. So the period for the function would be 2 pi over omega, where omega is whatever X is being multiplied by. Right? You have the function Y equals A sine omega x. We found out what A was simply by seeing where -1, where did -1 and +1 lined up. Okay, so that's our amplitude. Okay. And -1 got multiplied by +2. I mean, +1 got multiplied by 2 to get to. So because it went from here to here. So that's how I got the A part here. Now to figure out what was going on here, well, we have that the period is 2 pi over omega. That's one of the formulas they gave us. Well, my period here is 4. So I'm going to solve that. I'm going to solve that equation for omega. Multiply both sides by omega, and you get 2 pi equals 4 omega dividing by 4. I get pi halves equals omega. So this is going to be 2 sine pi halves x. So that's my function. Any questions on this? I'm looking at Zoom. Anybody have a question from Zoom? Or a statement or anything? Okay. So did I answer your question?
Yes, kind of.
Kind of. Because you understand we're working from this working model. Okay. And that the period is 2 pi over omega. So I'm going to find out what goes in here. It's just not sine of x now, it's sine of omega x. Because my period here isn't 2 pi. It's 4. So this is the period in the first quadrant. The period in the first quadrant is what we're looking at. And that's how we determine what the period is. And so 4 needs to equal the 2 pi over omega, so omega winds up being pi halves. So the graph has the characteristics of a sine function, and that's why I use sine. If the x-axis, I mean the y-axis was over here, then I would use the cosine function. And there's no shift up and down or left to right. It's all the transformations here are stretches and compressions or something like that. Well, they're all stretches. So, yeah, they looked at it being one period as being so they're gonna look at it the same way I did, I think. I hope. And so alpha is 2, the period is 4. And so then they come up with that same way I did. They came up with that omega is pi over 2. All right, and. Oh, okay, yeah. That was it. That wasn't so bad. Now, since it goes through 0, 0, supposedly, I'm going to use sine function again. So I'm going to say y equals not 2. Come on. A sine omega x. Okay. And yeah, I see the same thing they do where the one period here is from 0 to 8. So the period is 8, which is 2 pi over omega. So that means omega is pi fourths. I use one of the facts about fractions. If you have a proportion, A over B equals C over D, I can switch the A and the D, and it's still going to be equal. D over B equals C over D. C over A, sorry. So this 8 is 8 over 1, and this is 2 pi over omega. So I can just switch the omega and the 8. And so this is going to tell me that omega equals 2 pi over 8, which reduces to this. I mentioned recently that I play with numbers all the time. Yesterday afternoon, I must have said that about 7 times. Okay. So now we have now we need to just to figure out what's our maximum and what's our minimum. Well, our minimum here is -3. Our maximum is +3, but sine in the first one is supposed to be at 1. So I'm multiplying by 3, but not 3. I'm multiplying by -3. Does that make sense? Because sine goes this way. So we got our first extreme is negative. So that means we're multiplying and not positive. So we're multiplying by a negative A, and A is -3. So A is -3. So that means we have the function y equals the sine and -3 sine of pi force x, or pi x over 4. So they get the same omega. Since the graph passes through the origin but is decreasing near the origin, the graph is sine function that is reflected across the x-axis. So it requires A to be negative. That's kind of what I was saying. Only they said it more precisely than I did. Okay. The sine function. All right, we determined A is -3 and omega is pi/4. So there we have it. So far, it's been all easy peasy. Now the fun graphs. I hate drawing these graphs. Well, not hate, hate's too hard a word here. It's not fun for me anyway. So the graph of the tangent and the cotangent, the graphs of the function in the form of. So we have the same thing. Notice they threw in a plus b here. They hadn't had that before. That's the horizontal, the vertical shift. And I think the next thing we add is a horizontal shift, where we shift it to the left or right. And then the graphs of cosecant and secant and a cosecant of omega x plus b and a secant of omega x plus the b. Tangent function. This is over the first period in the first quadrant. Well, it's not the first quadrant. It's from -2 pi to 2 pi, because at -2 pi and at pi, tangent does not exist because you're dividing by 0. And so we're looking at, in the unit circle, we're looking at the first and second quadrants. That's the period of tangent is 1 pi. So we just look at those values, because in the next quadrant, these numbers, this just repeats itself in the next quadrant. And then the next and for the next period. So this would be one period, and this would be another period, and the numbers just repeat. Because tangent is positive up here and positive down here, negative over here and negative down here. So it starts negative, goes to positive, goes back to negative, and goes back to positive. So those values just keep repeating that. Now, see why I say it's not fun graphing this? Because it's just that dog leg over and over and over again. All right, as x approaches -pi/2 from the right hand side, the y values plummet. They go negative. Okay, and they keep going negative. But x will never reach -pi/2, so the y values keep going to -infinity. And as the x approaches pi over 2, positive pi over 2, as the x values increase, the y values increase. And since x never actually reaches pi over 2, that means the y goes to infinity or towards infinity. And so this period, this is one period, gets repeated here and repeated here and over here, and it gets repeated down here and repeated down here and on down. So now the key values are well, let's see what they say the key values are. The domain consists of all real numbers except odd multiples of pi over 2. So each of these are vertical asymptotes. So x does not cross, the graph does not cross these lines. So on one side, it's going towards positive infinity, on the other side, it's going towards negative infinity. And each of these are an odd multiple of pi over 2. The range is all real numbers, and you can see that from the graph because it goes towards negative infinity and up to positive infinity. So it decreases without bound and it increases without bound. So the range is all real numbers. It's an odd function, and that can be seen from the graph as well. It's symmetric with respect to the 0, to the origin. If I did 180 degrees on this graph, it would look exactly the same, except everything would be upside down. And so it's symmetric with respect to the origin. The tangent function is periodic with a period of pi. The x-intercepts are multiples of pi. Okay, and you can see that from the graph. I'm sorry to be bouncing back and forth between the two slides. Yeah, I uploaded a PDF version of this PowerPoint, and it's 6 slides to a page. So if you want one slide to a page, let me know and I'll go ahead and post that one up as well. Yeah. And the vertical asymptotes. The vertical asymptotes occur at odd multiples of pi over 2. So where the function does not exist, that is where the asymptotes are. Cotangent looks very much like cosine, but it's reciprocal. It's a reciprocal of it. So graphing those points, and then because it's a reciprocal, where tangent was 0, cotangent doesn't exist. And where cotangent didn't exist, where tangent didn't exist, cotangent is 0. So now all the x-intercepts are at the odd multiples of pi over 2. The range doesn't exist at multiples of pi. And the vertical asymptotes occur at the multiples of pi. And 1 period is 1 pi. So this is a period, and these periods are just carbon copies of each other. Yeah. Determine the domain and range. Okay. So 10x. So we're not messing with the period. The period doesn't change. So we're multiplying each y value by 3/2, multiplying by 3/2, and then adding 1/2. Isn't that fun? Let's see how they do it. Tangent doesn't come naturally. So the steps using these transformations. Okay. So we're multiplying each of these y values, the negative 1/2, the 0, the 1. So the negative 1, the 0, and the 1, they're going to multiply by 3/2, because that's what the function is. That's what A is telling us to do. We're multiplying each of the y values by whatever A is, and A in this case was what? 3/2. Right, so that's what they're talking here. So each of those y values, so negative 1 went down to negative 3/2, and positive 1 went up to positive 3/2. Now I would show the transformation in 1 period. And then I'd sketch it again for 2 more periods. But I concentrate on the first period. The period is from negative pi over 2 to pi over 2. Right. And now we're going to do the vertical shift by what was it? Minus or plus? Plus 1/2. So we're going to add 1/2 to each of these y values. So I'm going to add 1/2 to negative 3/2, which brings me up to negative 1. And then I'm going to add 1/2 to 0, which brings me up to 1/2. And then I'm going to add 1/2 to 3/2, which brings me up to 2. So it's like I'm moving my y-axis. I'm moving my x-axis up 1. Actually, yeah. And that's what they did here. They're kind of not doing what they usually do, is by having this slide, repeating this slide over, picture over here. And we're done. So I would show the transformations in here, and then just repeat them here and here, rather than or go up and then go back. I prefer up 1 and back 1 whole period for tangent and cotangent. But if you look at those points, you look at the points negative 4/2, negative 1, 0, 0, and then pi over 4, 1. What are the changes that are happening there? And then just knowing at negative pi over 2, there's a vertical asymptote. And at pi over 2, there's a vertical asymptote. And so these values make the graph look like that. And then the first transformation was multiplying the y values by 3/2. And so this went down to negative 4 pi. I mean, negative. Oh, that's supposed to be a pi there. Negative pi over. This was pi over 4. That's weird. Negative pi over 4. Negative 3/2. This stayed 0, 0. And this became pi over 4, 3/2. And then adding 1/2 to each of the y values. This becomes a negative pi over 4, negative 1, 0, 1/2. Pi over 4, 2. And so I graph those 3 points. And that would be these 3 points. And then I'd sketch in the vertical asymptotes first before I sketch in the graph. And then I'd sketch in the next and the previous vertical asymptotes and repeat these y values in here and down here as well. So this point would be here, and that point would be here, and this point would be here, and so it would go like that with the asymptote over here. So you're not looking at the entire thing, you're just looking at a portion of it, and then it just keeps repeating. That portion repeats. This used to be one of my favorite masks. Now it's one of my least favorite masks because it keeps dropping down. Of course, I didn't used to talk all the time either, because I wasn't in the classroom when I had it on. Okay. Oh, they're talking about the domain. Well, the domain remained the same because we didn't change anything with x. X didn't change. So the period didn't change, and we didn't do a shift in we didn't do a translation in the x values. So the range, so the domain remained that is all real numbers x, such that x is not an odd multiple of 2 pi. I mean pi halves. Okay, and then the real, yeah. With tangent and cotangent, you're really not going to change the range. If the range is from infinity to a negative infinity to infinity, it's really not going to change. Where are we time-wise? Okay. So cotangent. Again, we're using the same period of 2, but now the period is from 0 to pi. So we're just going here. And cotangent is positive and negative in the same quadrants, and so that's just gonna end up repeating like tangent did. But instead of going from pi over 2, negative pi over 2 to pi over 2, it's gonna go from 0 to pi. So now I look at, so now I'm gonna look at those key points. All right. So the key points at 0, I'm gonna have a vertical asymptote. And then at, what is it, pi over 4? Pi over 4, it's at 1, right? The pi over 4 is here. And that's x over y. I mean, y, yeah, x over y. And for pi over 4, cosine and sine have the same value, so that's 1. Square root of 2 over 2 divided by the square root of 2 over 2 is 1. And then at pi halves, cotangent is 0. Because this point here is 0, 1, and it's x over y, so 0 over 1 is 0. And then at 3/4 pi, that's in this quadrant over here, it's gonna have the same value as this, except it's gonna be negative because cotangent is negative over there. So it's -1 here. And at pi, we have another asymptote. For cotangent, the period is pi over omega. So this means I'm going to change my period, because now this is going to equal 2. Which means that omega is going to equal pi halves. So I'm going to divide each one of these x's by, well, there's an easier way of doing it. It's saying now omega is pi over 2. No, omega is 2. I'm sorry. Omega is 2. So this is pi halves. So that means I'm going to multiply each of these x values. I'm going to divide each of these x values by pi over 2. So that means I'm multiplying by 2 over pi. So I'm going to do 2 over pi times pi over 4, which is 1/2. 1. Well, let me do it this way. Go back to my number 1, right? So now it goes, instead of going from 0 to pi, now it goes from 0 to pi halves, and I take the halfway point, which is pi over 4, and then I have pi over 8, and then I have 3 pi over 8. So these are my my 5 key points, or my 5 key numbers in my axis. Where now I have the vertical asymptote at 0 remains, and now my vertical asymptote got moved from pi down to pi over 2. So this is still at 0, but now this is at pi over 2. And instead of being pi over 4, now it's pi over 8. And instead of being half a pi, now it's a fourth of pi. So I haven't done anything to the y values yet. And so 3/4 pi becomes 3/8 pi. All I did was exchange my x values with these numbers, because I changed my period. And I'm going to change each y value by multiplying by 3. So 3 times 1 becomes 3. 3 times 0 didn't change. And 3 times -1 is -3. And my asymptotes didn't change. Once I changed my period, the asymptotes become rigid. So I graph these points. I know my graph, my first period is between 0 and pi over 2. And so that's where I have my, I'm going to use a different color for the asymptote. So I have an asymptote on the y-axis. And at 1/2. And so the halfway point is on the x-axis, so this is at pi over 4. And then at pi over 8, we come down to -3. And at 3 pi over 8, we go up to, no, we were at +3 here, I'm sorry. +3. And then here we're at -3. And so it comes down. And there's a slight dog leg and continues down. And that's the graph. And then I would repeat it over here. So that would be to negative pi over 2. So this point, and this point. And I put in that asymptote and I draw it in here. And then over here, from half a pi to pi, and then halfway between, so that's there, and then halfway between here, I'm up here, and halfway between here, I'm down here, and then I draw on that line. And there we have it, not drawn to scale in any shape, way, or. Okay. So they're gonna use the steps. And what was the first thing they did? Multiply by 3, so they did the vertical stretch first. Where I looked at what happens in the period. So they did the vertical stretch. So, and they only did 2 periods, so they pulled them away from the x-axis by multiplying by 3, so they got stretched upwards and downwards. And then they threw in the 2 omega, I mean, where omega is 2. And that just scrunched it towards the y-axis. I wish they had kept this up there, because what happened is that these 2 periods I shifted down to here. So now, instead of the 2 periods being between 0 and 2 pi, now these 2 periods are between 0 and pi. So they got squished this way. You want to live with that. The domain, well, the domain changed because we changed our period. So it's at 1/2 pi, 3/2 pi. So it's going to be a multiple integer. It's going to be an integer multiple of pi over 2. The even multiples as well as the odd multiples. So it wants to include each half step. So each half pi. So 1/2 pi, 2/2 pi, 3/2 pi, 4/2 pi, 6/2 pi. And then the range didn't change. And we'll start with secant next time. PowerPoint saw that I was done for the day, so it closed on me. I had nothing to do. I don't know what it did there.
Quick question.
Yeah,
Our course syllabus says that the exam is gonna be on the September 22nd. Is that gonna cover everything that we have until now, or sort of Monday?
so Monday is the day before the exam, right?
22nd, I believe, is Wednesday.
Next Wednesday.
Yes, sir.
So everything up till, today,
Everything up to today?
everything up to today.
Okay, not Monday.
No, Monday is the review.
Okay.
So that, fucking hell, I got a lot of work on my plate, and I just put a mountain more. So between now and Saturday, I'm gonna come up with a review and post it in files.
Okay.
And I expect y'all to at least look at it, if not work it. Well, at least work half of the problems. Because I'm not gonna go through in class, I'm not gonna go through every problem. I'm gonna answer questions. So if you have a problem there that you look like it's gonna blow your brains out, then bring that up in class.
Okay.
Or send me an email, we'll discuss it. So, that's how the reviews work. And I found this out the other day. My daughter, one of her friends at work is taking math class. She's taking college algebra at St. Philip's. And so she sent me a text message asking about a problem. And both my daughter and I said, that's a stupid question. It was it was a proportion problem, and how they were asking it was wrong. And I understood what they wanted, because it was a proportion problem, but it was asking it in statistics. But they didn't have the proper statistics down to use the proportion correctly. And so, but we got through okay. And then another friend of hers is a friend of well, they work together. And looked me up and rate my professor. And I didn't realize that people want. I got good reviews and rate my professor, except for 2015. And we figured out that was the year my wife had a stroke. I'm surprised in 2013, 2014, I didn't get bad reviews, because that's when I broke my ribs. 5 broken ribs. Yeah, be sure you sign out or sign in for whatever the proper phrase is. For those of you in Zoom, y'all can be disappeared now if you want to be. Because. Okay, it scared me because nobody was saying anything. All right, so yeah, the review is on Monday and the test is next Wednesday. So everybody's covered. Okay, yes, ma'am.
I just had a question. I was wondering if there's any chance I can take classes online, like this class for like an online. Is it possible at this point?
Well, you're still going to be in this class.
Yeah.
Okay, so for as far as ACES is concerned, you're in this class. But
It's just that sometimes I forgot like